lesson 3-6. Today we're going to be talking about writing two-step equations. So last lesson we went ahead and we solved them and we went through all of the steps. But this time we are going to be looking at word forms and we are going to be able to turn them into equations and expressions. Now, what I did was go ahead and write a two-step equation up here for us. So 2x plus 1 equals 10. And then I went ahead and transformed it into word form so that we could see it this way first so that we'll know how to do it in the reverse. So this is the same as the sum of 2 times a number and 1 is 10. So I went ahead and I broke apart all of the key terms that told us what to do in this equation. So the first term is sum. So we know that sum is the answer to an addition problem, which means that we're going to be adding in here. So here's our addition sign. So we're adding two numbers. Now what are we adding? So the sum of 2 times a number, so here's 2 times a number, and 1. So 2 times a number and 1. Is always means equals, so equals 10. So equals 10. So this is 2 times the sum of 2 times a number and 1 is 10. So basically we're going to do a few practice problems where we're writing them in the form and then some of them you're going to be asked to solve them as well. So you're going to have to write the equation and then solve for the variable. So let's go ahead and do a few more examples. Alright, let's go ahead and look at example number 1. So example number 1 says 3 more than 4 times a number is 23. So we are going to break apart our words. So we need to know what our key terms mean and what operations they stand for. So first of all, we see the word more. So that I know that I'm going to be adding. So what am I adding? It says 3 more than, so I'm going to be doing 3 plus 3 more than 4 times a number. So I see the word times, which means multiply. And what are we multiplying? So we're multiplying 4 and a number. Now, anytime it says a number, you cannot just plug in a random number. That just means that that's going to be our variable because we don't know what it is. So we have 3 more than, so 3 more than 4 times the number. So I'm going to choose a variable. So 4 times, I'll just choose x. Is, so is means equals 23. So this is 3 more than 4 times a number is 23. Let's go ahead and do another example. Number 2 says the quotient of a number and 3, 8 less, is 16. So we're doing several things in here. So first of all, I see the word quotient. So I know I'm going to be dividing some numbers. So the quotient of a number and 3. So we're going to be dividing a number, which we do not know, so it's going to be a variable, and 3. So we're going to divide our number by 3, and then it says 8 less. So when I see the word less, it means subtract. So I'm going to subtract 8. Is, which means equals, 16. So this is the quotient of a number and 3, 8 less, is 16. Alright, this last one is a word problem, so we're going to have to kind of pick it out, the equation, a little bit. So it says Linda is 5 years older than Cole. The sum of their ages is 37. How old is Linda? So we're going to be using the information we know about writing equations to be able to solve an equation. So first of all, it's asking me how old is Linda. So we do not know Linda's age, so I'm guessing that that's going to be our variable. So I'm going to choose the variable L to represent Linda, just so that we remember what we're solving for. Okay, so L is our variable. Now what are we doing with this variable? Now it says Linda is 5 years older than Cole. The sum of their ages is 37. So I see the word is 37, so I know that the equation is going to be equal to 37. I also see the word sum. So that means we're going to be adding two things. And what are we adding? The sum of their ages. So since we don't know what their ages are, we're going to have to come up with their the variables. So Linda we have Linda's age, and her brother. Now her brother is 5 years younger than she is, because it says that Linda is 5 years older than Cole, so that means Cole is younger than her. So Cole is L minus 5. So here we have Linda's age, which is L, and we have Cole's age, which is L minus 5, equals 37. Now, if you look at this equation, we can't just solve yet because we have to combine some like terms. So I see the L and L. So I'm going to go ahead and add our L's together. So 1L plus 1L gives us 2L, and then subtract 5 is going to give us 37. So now we're going to go ahead and use what we did this last lesson to solve for how old Linda is. So first step, we have to go ahead, since we're solving for L, we need to get rid of our term that does not have our variable in it. So first I'm going to do the opposite of negative 5, which is adding 5. And I've got to add 5 to both sides. So I have 5 canceled out there. And then, let's see, 5 plus 7. So we're going to get 42. 2L is equal to 42. Now our last step is to divide, because we have 2 times L gives us 42. So we want to do the opposite. So instead of multiplying by 2, we're going to divide by 2 on both sides. So once you divide 42 divided by 2, 2 goes into 4 2 times. So that's going to give us 4, 0, and then 2 goes into 1 one time. Or 2 goes into 2 one time. So our age is that Linda is 21 years old. So now let's go ahead and check ourselves. So it says that Linda is 21, and it says that her brother is 5 years younger. So if you take away 5 from 21, you're going to end up at, so we have 21, 20, 19, 18, 17, 16. So plus 16 should give us 37. Does it? Let's see. 6 plus 1 gives us 7. 2 plus 1 gives us 3. We are right. So Linda is 21 years old. All right. If you have any questions, or if some of this was a little bit confusing for you, rewind, watch the video again, come with your questions tomorrow. Now let's go ahead and look at your on your own questions.
You have 2 problems to solve for me. The first problem says 4 less than twice a number is negative 2. Number 2 says, suppose the current temperature is 17 degrees Fahrenheit. It is expected to rise 3 degrees Fahrenheit each hour for the next several hours. In how many hours will the temperature be 32 degrees Fahrenheit? Alright, good luck. We'll see what you get tomorrow.